In this video, we will take up the homework on max-min problems. For question 1, you have basically a flare, you're shooting up into the sky, you have the equation, so what's the height after 3 seconds? Just let t equal 3. What's the maximum height? So you can do different things. Complete the square, negative b over 2a. I chose the negative b over 2a. What's the height of the flare after 25 seconds? Well, you get negative 625, which makes no sense because it's already hit the ground after 25 seconds. So yeah, you really can't dig a hole using this flare. So once it's hit the ground, it doesn't make any sense. You have to stop using the model. So I just want to change the wording here. The flare has already hit the ground by 25 seconds. It's long gone. Because I think, let me just try quickly do the math. It hits the ground after 20 seconds. Yep, it hits the ground after 20 seconds. So by 25, it's just basically on the ground. It's not going to dig a hole. For question 2, basically you have an equation and you're finding the vertex. So I broke it. They break it down to 2 parts. They want the independent variable of the vertex and the dependent variable of the vertex. They want you to interpret it. So I did the negative b over 2a method. You can complete the square. Okay, for question 3, this is a great question in the sense that it's building off what you did in grade 9. Because if you're given the area, if you're given the perimeter of the rectangle, how do you maximize the area? And the answer is to build a square. Okay, but just in case you forgot, this is how you do it. Okay, in fact, we want you to really do this question and say, wow, this is great, because you're able to work with quadratic relations. You can now prove what you learned last year, because last year the teacher just said to you, yeah, just build a square, that will maximize the area, but there was really no proof. Okay, you just probably built a whole bunch of different squares and built a bunch of different rectangles and said the square was the best idea. But you never know, there might have been a better design. But number 3 clearly shows that the square is indeed the perfect design. And then number 4 was also building off of what you did in grade 9, which is if you have one-sided that is blocked off, you don't need to fence off, then what's the maximum area? Which is the double square rectangle. Anyways, this is to prove that it actually works. Okay, for both 3 and 4, you have to perform a substitution. So I really like that question. I like that because it gives you good practice on doing those type of questions. Students usually struggle with that. Question 5, great question, because you have a revenue question and you're trying to find out. So for 5A, what is the selling price that will produce the maximum revenue? So I found the zeros and then I just averaged them, and then I can solve for the max price, or the best price to maximize the revenue, by letting x equals 3. So I should do 3 price increases. So it would be silly for me to expand, because I really didn't need to expand and then do negative b over 2a. For 5b, what's the maximum revenue? Well, I know I should do 3 price increases, so find out the revenue after 3 price increases. For question 6, another beautiful revenue question. Okay, great practice. Anyways, I extracted the zeros from factored form, average the zeros, and then I can tell them what's the best price. They don't even care about what's the max revenue. They just ask what the price should be in order to achieve max revenue. Last one, question 7. You're basically given the zeros and a point. You can solve for the equation in factored form, and then you can use the zeros to find the vertex. Yep. So basically, build the equation in factor form, and then you do what you want. But the whole idea is to find the optimal value. Okay, so that's it.